Let's take a quick look at a quick scan using the new Tektronix Margin Tester, the TMT4. It is built for Gen 3 and Gen 4 PCI Express, and it's a link health checker. So we're looking at the web GUI, and in the setup, we're going to do a quick scan. There's not a lot going on here. It's a very quick tool to give you a good idea of the link integrity. So we can check the link, and I've got a link that's a Gen 4 between the TMT and a M.2 SSD mounted onto the slot adapter, as you can see in the camera. So I'm going to click Run the Scan. And what's going on here is the TMT forms a link with the link partner, in this case the drive. So the TMT is going to work as the root complex and the drive is going to be the endpoint. And they are negotiating, going back and forth and doing the link equalization and training. And you can see each of the lanes come up and see which presets they negotiate to. And then what our receiver used for its equalization schemes. And then an eye diagram inside the receiver. So you can see that those four lanes overlay pretty closely to each other. And there's not a lot of variance. And we just tested the device under test transmitter as trained. And so that's the key for the quick scan, is we're going to test it as trained. So in this case, one lane tested and trained. So it trained to a 9 for the preset and tested a 6, a 9, and a 6. And you can run this device over and over and you will see 9s and 6s typically for this device as it trains up. So as trained, we test the transmitter, and this is the signal quality that made it to us. And that is going over the full compliance channel. So we're eating up all of the loss allowed per specification in this test setup. The other thing that it does is we do a receive test on the device under test. Often people will confuse this with the lane margining tools that are from the silicon vendors. What those do is they are testing the receiver, but they're testing the receiver in the horizontal or timing axis here. So they're shrinking down the timing and finding out when they get errors. So this is a complementary test, and what we're going to do is we're going to shrink the amplitude. And so C0 is the main cursor tap for the transmitter. In this case, the transmitter is coming from us in the TMT. And we're going to run that down from full amplitude, and we're going to shrink the amplitude of that main cursor, thus driving down the voltage swing until the receiver reports back that it has errors. So you can see lane 0, we were able to shrink that main cursor down until it started receiving errors at a 24 setting. For lane 1, it made it down to a 22 setting. So you can see the variations of the different lanes and how much amplitude degradation they can handle before the receiver reports it has errors. So both the transmitter DUT test and the receiver DUT test are complementary to what lane margining tools are out there from silicon vendors. So this offers a new set of tests available for quick and easy. And notice again, that test ran really fast. So another thing we can do is, what is this? It's not a scope, it's not a BERT, it's not a protocol analyzer. It does a little bit of all of the above, but it tests really quick. So let's run that test again. And this time, I'm going to take a touchscreen pen and I'm going to put it on one of these traces. So I'm going to hold down a touchscreen pen. So basically, we're going to add some capacitive, or those, it's one of those conductive tips for a touchscreen. Let's run the scan again, now adding just that little change to the impedance of the things. And again, as it's doing this scan, it's going through link training and doing a negotiation between these two endpoints. So we're running the tests again, and we'll see what it comes up with for presets, and we'll be able to see again the equalization schemes chosen, and thus the internal eye diagrams as well. So you can see that I've affected lane 2. It's quite a bit smaller than it was before, and it doesn't line up as well with the other ones. And if we click on that lane 2, you can see how it's now amplitude. Its amplitude was up here in the 60 range, and now we're down to close to 40. So we've lost 30, we've lost 10, we've lost almost 20, maybe 30 millivolts of eye height by just having this conductive pen touching these traces on this adapter. So what this box is going to do for you is quickly find where you have an outlying event on one of your lanes. And now I know, based on looking at this, that if I wanted to go check the signal quality, I would use my scopes and BERTs and protocol boxes or whatever. I would go do my SI work with my expert engineers, and I would focus it on lane 2 because it is the one that has the biggest change. So that is a quick look at what a lane margining tester, the TMT4 from Tektronix, will do for you.